Okay, so these are both negative charges, which means they are like charges. And as we saw before, like charges repel. So in this case, they're going to push away from each other. So the one on the right is going to move to the right. The one on the left is going to move to the left. All right, and just in case we want to verify that, if I take this back to the practice and I clear the board, and let's say I put, let's see, I make the puck negative now, and this is negative, they're going to repel it. Clearly, they start to push each other away. If this one could move, it would go the other way as well. Okay, so once again, like charges, things that are alike tend to repel each other. They don't like being in the same space. Now, if these two things are getting pushed away from each other, now I have positive and negative. These things clearly are opposite, and as we talked about, opposites attract. So this means these two things are going to start to move towards each other. Okay, and just like this, this would go to the left, this would go to the left, this would go to the right. Okay, and what we're just focusing on right now, ladies and gentlemen, is just the idea first that these are all forces, which means these things move, they follow the rules of kinematics, they follow the rules of any sort of motion we've talked about, and they follow the rules of forces. Okay, and I can figure out, honestly, I can easily figure out what the acceleration of this object would be if I knew its mass, and I could calculate the electric force. All right, now, the last piece of this, and kind of the last piece of this video, is I have set up two little drawings, okay? And you are going to draw FBDs for these objects. Now, just like we've done before, even though this is a new type of force, I promise, all the rules of forces still apply. So you're drawing an FBD, you're thinking about which way the force is pulling, making sure they go in that direction, all right? Now, just to make this easier, we can assume that gravity is not acting on any of those, so maybe it's just sitting out in the middle of deep space somewhere. So, same deal, I want you to go into Edit, and just take about a minute and a half, and I want you to kind of just sketch where the forces are, and if you could, just make a little text box, put FE for electric force. Okay, and just kind of put it next to that because that's really the thing we care about. So, take about a minute and a half, please, ladies and gentlemen, to draw the FBDs. Okay, take about another 30 seconds, please, ladies and gentlemen. All right, so if we're drawing the FBDs, I'm just going to go through and just kind of use these little arrows, but we just go back to the ideas of electric forces, okay? Opposite charges pull each other together, like charges repel each other, they push each other away, okay? Now, we're drawing an FBD, and I apologize, I didn't specify that, but if you look at the notes, you're drawing an FBD for this box right here, okay? So if you didn't do that, I'll give you another like 15 seconds. Okay, so in this case, the way this is set up is this box is being attracted by this negative particle and this negative particle as well. So it actually experiences two electric forces, okay? One's going to be going to the right, one's going to be going to the left. And right now we don't really know anything about what those are equal to, okay? After we do the lab and talk about how we can actually calculate it, we'll know. But right now, we're just going to say this is just Fe for electric force, okay? And since that is what's providing both forces, oh my goodness gracious, nope, pardon me. It's nothing like trying to edit a picture that really shows how with it you are with technology. Perfect, okay? So Fe there, okay? Now, right there, we're just seeing the idea that these electric forces, gracious, never mind, I'm not going to bother trying to get that equal. Just seeing the idea that we can draw FBDs just like normal. And the same thing is true over here. This time I have a negatively charged square next to two positively charged circles. So the two positively charged particles are going to pull on that box. So now we're going to have it being pulled to the right and to the left. And what we'll find out is that if we set it up just right, we actually can have this box be set up in equilibrium. Because looking at it, if it's pulled equally to the left and equally to the right, the net force would actually cancel out to equal 0. Okay, and we're going to find that that actually is a very important thing, especially once you start to get kind of more advanced physics that involves particles. Understanding how you can kind of trap certain particles can be very useful. All right, but just going to save and close. So, just to kind of review, this is our first step in the idea of electric forces and electricity. All right, in this case, we're just talking about the idea of electric force. That there are 3 different particles we care about, but only 2 that have a charge. Electrons have a negative charge. Protons have a positive charge. Neutrons ain't got nothing. And that's the way they like it. We know the idea that like charges repel or push each other away, and opposing charges attract each other or pull each other together, and that means they're exerting a force. And then we talked about the idea of just what that can look like when we did our little electric hockey demo. The idea that the unit of charge is a coulomb, so we measure the amount of charge something has by the amount of coulombs it has. Okay, and it's usually really small. An electron, a single electron, has 10 to the negative 19th charge, basically. That's really, really small. Then we just discussed the idea of how things will move if you let them go due to electric forces, and then the idea that we can draw FPDs. All right, so with that being said, that's the first step with the idea of electric force. The next video you're going to work through, which is the next page of this document, is a lab where you're going to work through and actually figure out how we can calculate how much force a particle is exerting on another charged particle and kind of decide how all that stuff is related. All right? So, with that being said, ladies and gentlemen, excellent job with this side of the notes, and you can head on to the next part of the lab.